All right, welcome to going over our graphs. We're looking at 4.5 worksheet graph trig other form B. So we're going to start with number 5 because you should be able to fill out 1 through 4 on your own. We can start with filling out the range. For cotangent and tangent, we always have all real numbers for our range. When we start looking at this, we need to figure out what numbers are here. We have y times cotangent of x. We have nothing besides that information here, so that means our amplitude is going to be 1, and for cotangent and tangent to find our period, we do pi divided by b. And since we don't see it here, our b is 1, so we would just get pi as our period. Alright, just like how we have 1 for a and b, since we don't see C or D, that means there's 0, which means we will not have a phase shift and we will not have a vertical shift. So before we start trying to fill out asymptote and domain, I always like graphing it first. We do have our formulas for it now, which we can review during class on Monday. So since we don't have any shifts going on, we can draw just the x and y axes straight down the middle. We could draw that real quick. And now we can actually start talking about what our scale should be. The general rule of thumb is we can put a tick mark halfway on each axis, and we'll talk about how to label that, but that will allow us to see our entire graph. So for the y-axis, we can put a tick mark halfway up and then halfway down, and that will be how far up and down we go using our amplitude. We can use this pretty quickly because we don't have any shifts. It gets a lot more complicated when we start having shifts. Next up would be the x-axis. Cotangent, we already said our period is pi. For this type of shortcut, we just go pi to the right and then pi to the left. So we really only do need 2 tick marks, one on the left, one on the right. And we can just do that halfway in between the edge of the graph and our y-axis. So let's start labeling these. We need to go over a period, so that would be pi to the right, and then over to the left a period, so that would be negative pi. Whenever we're graphing trig functions, we should always want to split our period up into quarters. For every type of trig function we have, we will be following that pattern. So we can draw that physically on our graph, but here we actually have lines there, the blue and the red lines. So if we look at our notes to see what cotangent looks like, our S-curve isn't centered on the y-axis. Instead, our first vertical asymptote is centered on the y-axis. So we can start drawing that down the y-axis. That's our first vertical asymptote. For our other trig functions, which means tangent, cotangent, cosecant, and secant, we will have vertical asymptotes. We should always start graphing our first one, and then we go a period to the right to graph the second vertical asymptote. So that would be 0 plus pi, so we would draw our second one at pi. And then for cotangent, we can get started drawing our dots right away. For cotangent, let's just talk about the curves first. Our cotangent curve will look like the one I just drew up in the top left, and that's cotangent. Don't confuse that with tangent, which is more of a positive looking. Notice how the T for tangent also looks like the positive sign. C doesn't look like the positive sign, so that should be the negative S that we're looking at. When we start drawing our dots, though, we'll be splitting our period into half. That's where our first dot goes, and that goes up or down according to our vertical shift. We have no vertical shift, so our first dot is going to stay at the x-axis halfway through our period. Since we're doing cotangent, we're going to go over a quarter of the period and then down an amplitude, and then we're going to go to the left a quarter of the period and up an amplitude. That would be opposite of how we would do it if we were graphing tangent. And now that we have our 3 dots and our vertical asymptotes, we can draw an S-curve that goes through it, and so that it looks like it's slowly approaching those vertical asymptotes but never crossing it. So that would be our cotangent curve. one cycle, but let's draw another cycle as well. So if we started our first vertical asymptote at the y-axis, that means we would need to go over to the left to draw our second cycle. So we would need to start at 0, go to the left a period. So we're going to draw a vertical asymptote at negative pi. So that's our second vertical asymptote. So same process, we're going to put a dot in the middle, and it's going to stay at x. We're going to go over to the right and draw a dot down in amplitude, go over to the left a quarter of the period, and up in amplitude. So that's our first dot right in the middle, and then we go to the right a quarter of the period and down, since we're doing cotangent, to the left a quarter of the period and up. Draw that beautiful S curve so that our graph looks like it's approaching our vertical asymptote. Let's not forget to do our domain and asymptotes. So first, it's easier to start with asymptotes. So first we need to figure out our common difference for cotangent and tangent. That will always just be our period. So we can start writing that, which would be x equals, and our period is just pi. And then we multiply that by k, which just represents a positive or negative whole number. So notice how our first asymptote is at 0, which means k is 0 there. Our second asymptote is at pi. It's 1 times pi, so k is 1 there, and vice versa on the left, k would be negative 1. We should be putting a plus or minus there, and that would be dealing with our phase shift, how far our vertical asymptotes get moved over. Here, the process that we do it, we look at where we started our asymptotes, which would be at 0. So since our first asymptote is 0, we could put plus 0 there, but it won't change anything, so we just keep it there. If we look up at the domain, the only difference between domain and asymptote is that we need to change it from x equals to x can't equal, because our domain is all the x's except those at the vertical asymptotes, because our function never actually goes over that. So when we write this, we have x cannot equal, and then we have pi times k. Alright, so we're going to go down to number 6 now, and we're going to start talking about cosecant. So I already started looking at it. Let me get rid of that. So we can try to do domain and range first, and we do know our quick shortcuts for that already, but I still like doing amplitude first, graphing it, and then filling in the other pieces. So amplitude is our first one. It always matches what our A is. So here A is 1, so our amplitude is 1. We finally have another number involved in our graph now. So our period for secant and cosecant matches our period for sine and cosine. So to find our period for these, we always do 2 pi divided by b. And here our b is 2, so we do 2 pi divided by 2, which when we simplify it, we get pi. So we'll talk about how that's going to affect our graph in a second. Our phase shift, we don't have anything for C or D, so that means we don't have a phase shift, so NA, or you could write 0, vertical shift NA or 0. So that's what we have right now. We'll come back and do domain and range after we graph it. You could do it right away if you remember our shortcuts. So as I said for the other one, since we don't have any shifts, we can draw our axes, our typical axes right through the middle of our graph. And here, if we look at our notes, we have the same deal as number 5 for cotangent. For cosecant, our first vertical asymptote is centered on the y-axis, unless we have a shift, but here we don't. So we can get started on that, but first let's actually write our scales. So as I said for number 5, I like it just a short, fast way of just putting a tick mark halfway up and halfway down the y-axis, and that would be our amplitude, so 1 and -1. And then likewise on the x-axis, put 2 tick marks halfway on the right and the left, and we can just put our period there. So pi and -pi, because we're on the left. as I said for the other one, we're always splitting our period into quarters no matter what trig function we're graphing. So here, lucky enough, we have quarters, but we could always put in tick marks so we can see the quarters a little bit more clearly. With cosecant and secant, we have a lot of vertical asymptotes, but for cosecant, our first one is on the y-axis. So we can start drawing that. So here is our first vertical asymptote. We should always start with our first one, and we always look for our phase shift to help us out there. We don't have a phase shift, so we just look at our parent function in our notes, and we know we start at the y-axis. The second vertical asymptote we draw is at the end of our period, which is pi away. So I'm going to start drawing that vertical asymptote that goes through pi on the x-axis. And then we have to draw another one. Because we have cosecant, we should always be drawing a vertical asymptote halfway through the period. So here, I'm not going to label it, but that would be at pi divided by 2. So now that we have our vertical asymptotes, we can actually start drawing our cosecant curve. And remember, cosecant and secant are the ones with the upwards facing u's and the downwards facing u's. We always start with the upwards facing u, which is it's the first one we draw, and it's usually in the more left part of our curve. So we're going to go over to the middle of our first two vertical asymptotes and draw a dot that's one amplitude up, and then we can draw a u that goes through that. And then in the other space that we have, we put a dot halfway between our two vertical asymptotes, but now we're doing it at amplitude below the x-axis. So we can draw those dots. We can draw that dot there, and a downwards facing u in between. That. Remember, because our vertical asymptotes, our u should look like it's getting really close to the vertical asymptote, but never crossing it. When I grade your quizzes and tests, I'll always be looking for these dots. As you can see, my u's don't look perfect, but I did make sure I put my dot at the exact space where the u should do its turnaround. So we need to draw a second cycle. So we have our first vertical asymptote still at the y-axis, and if I draw a cycle to the left, I would go left a period. So that means I would draw a vertical asymptote at negative pi, and then I would need to draw one halfway through that, because we always have another vertical asymptote halfway through our period. So that would be negative pi over 2. And then I'll be drawing my u next. I like doing it just right from the y-axis. So since I have an upwards facing one to the right, I'll have a downwards facing one on the left. So I can put my dot halfway in between our two vertical asymptotes and an amplitude down, and then just draw the u in between it, in between the two vertical asymptotes. Likewise, if I go over left again, I'll put a dot halfway in between our vertical asymptotes, but then an amplitude up, and then just draw an upwards facing u at that dot. So now that we have our graph, we know we have two cycles because we go upwards facing u, downwards facing u, and then upwards facing u, downwards facing u. So we have two full cycles, and now we can start talking about the parts of our table that we don't have filled in. First should be range. We're looking at, if we start at the bottom, how far down could we go to how far up could we go. So because we have these u's, we can start at negative infinity. So we should have parenthesis, negative infinity, and then we start looking up, and we go to negative 1. Remember in class, the shortcut was d minus the amplitude. Here our d is 0 minus 1, so we get negative 1 the shortcut way, or by looking at our graph. And we have a square bracket at negative 1, and we're going to union that with where our u's start up at, which would be d plus a, so 0 plus 1, so positive 1, and our u's go up to infinity, so infinity and then parenthesis. Next up will be asymptotes. So we're looking for a pattern. We always look for the common difference in between our vertical asymptotes, which for cosecant and secant, that's half of the period. So if we look at our period, we have pi. So our asymptotes would be, the common difference between them would be pi over 2. We could also see that in our graph too. So asymptotes, we do x equals, and then the common difference, which would be pi over 2. We always multiply that common difference by our constant k, which represents positive or negative whole numbers. So I'm going to add in my graph what that pi over 2 represents. So that's where that that's where that vertical asymptote would be at, because we have one at 0, and then the common difference would be pi over 2. So let's multiply that by k. Sometimes we have a plus or minus number here, but we can choose a very easy first asymptote. We could always do numbers here because we have this k here. We can start at any vertical asymptote we have in our graph, but we have a very convenient one, which is the one at the y-axis. That is 0, so we can do a plus 0 or just not write anything at all. So see how we have that vertical asymptote at 0. So we can just not have to add or subtract anything to our vertical asymptote equation. So for domain, it's the same thing as asymptotes, but we have x cannot equal, and then we just copy what we did for asymptotes. So pi over 2 times k. So that means if we're looking from left to right, we have a very full domain except where we have those dotted lines at our vertical asymptotes. Thank you for listening. I'll pick up in a second video on the back of this worksheet.